the last video of this class, part 8.4, estimate the cost. All right, so now what do we need to do at this point? Count the number of multiplications to evaluate this polynomial. All right. When we count, we may do some divide and conquer. So let's divide the whole polynomials in several portions. Here, term by term, we have many terms. Can we count the number of multiplications for each term? Right? That should be easier. For the general term, we represent as a sub k times x to the kth power. All right? After that, if we can find that number first, to get a total, we add up all those numbers. So that's simple. The idea is that simple. Now let's do the work. To do the work, let's look at how many multiplications do we need for this expression here. Although the problem is not hard, this is an easy one, but here we can still apply some strategy we can use here in this situation. Here, I recommend one strategy. Later, we will use it again and again. All right. The strategy is try simple examples. Try simple examples. Then you can get idea. Then you can summarize some rule from those simple examples. Here, let me show you how to do it. Okay. Because this k can vary from 1, 2, 3, n. All right? Yeah. So here, let's try this. When n equal, when k, here, because we use k as our variable, when k equals 2, that's simple case, right? Simple case. Yeah. So you need to look at the number of multiplications for this expression. How many multiplications? Right? That's easy. Everyone can get it easily. So x2 times x times another x. Okay? So the answer is 2. Right? Okay. So let's try another simple examples. a3 x cubed. How many multiplications? a3 times x times x times x. Answer is 3. Is there any rule you can observe from these experiments, right? So when k equals 2, your answer is 2. When k equals 3, your answer is 3. Do you get the rule? By induction, this looks like induction, right? So the answer is k, right? For the general k, the answer is k. Okay, so you can even prove it if you like to prove. All right. Anyway, you find the answer. Okay. Yeah. So from this example, you find the answer. Answer is k. Okay. Now we can go to the next step with this answer k. Okay. Now we want to add up all the number of multiplications for the individual terms and get a total. Yeah. So let's do that part of the work. All right. Here, I draw this chart and put the number of multiplications for individual terms. Right? To get a total, we do summation. all these numbers. Do you know the formula? What is the formula to get the summation? Yeah, it's pretty, it's a famous formula. Yeah, very famous formula. Okay? Answer is this: 1/2 times n plus 1. Okay? So we put that expression, let me say expression under the total. Now we are ready to calculate the total number of units for this polynomial evaluation. It's this number. Why? For addition, n units we calculate before. The first video, we calculate before. Okay? Or previous video, not the first. Then multiplication, this expression, number of multiplication, we know each multiplication we use 10 units. Remember our two assumptions. So 10 times 1/2, that's why we get 5. Okay? So the final expression is like that. So now we get the answer. What's next? What should we do in the next step? Look at this question. How to reduce this number? Is it possible for us to improve our method? That's a very important question for this algorithm class. We always ask ourselves this question when we finish one algorithm. All right. Improvement strategy. So when we want to do the improvement, we may need another strategy. Okay? So you can see strategy by strategy again and again. Yeah. To get a new strategy to solve a new problem, right? Yeah. So although this problem, but we want to improve it. So we need to overcome a new problem. All right. In this situation, usually we rely on our observation. Observation is very important. You should have very good observation if you want to be a good problem solver. Yeah. So for the observation here, we want to get some important property. Observation, try to find some property here. So let me point this critical part. Cost ratio. When we consider the computation cost, we have two parts, addition part and the multiplication part. Here, let us do the ratio on the unit cost for multiplication over unit cost for addition. The answer, based on our assumption, is 10:1 ratio. That's pretty big, 10:1 ratio. That's a pretty big, relatively big number. Yeah. Conclusion. After observation, you need to give some conclusion. Can you try to make some conclusion from this observation? Right? The conclusion is focus more on multiplications. Multiplication has more weight. Or, in other words, multiplications dominate the total cost. Dominate the total cost. So that's why we should put our effort on multiplication to reduce the total cost. That's the conclusion. All right. So let's make summary for this step, strategy. So we get our strategy. After the conclusion, we, convert it to another strategy we need. Reduce the number of multiplications. All right, so let's keep going to solve this problem. Next, implement the strategy. We have the strategy. So the next step, we need to consider the implementation details. All right, so we inherit the strategy put here from the previous slide. Yeah. And we want to look at the total cost expression. Total number of units, time units used to calculate this polynomial, this expression. When we look at this expression, we can easily see the total cost for two parts. For the addition part, only n. For the multiplication part, 5n times n plus 1. So you can see our strategy really makes sense, targeting the, the big dominant block. All right, yeah. So let me review our, early view on the algorithms. Yeah. Early view. Yeah. Strategy gives us direction to go. Where to go? Direction to go. So what you are going to do. Yeah. Execution tells us how to get there. Right? The details, implementation detail, how to get there. You need to know that also. Otherwise, you cannot get there. Right? So these two parts, both important. All right. So next question. How to reduce the number of multiplications. That's our execution part. So we focus on this part. Yeah. All right. Now we need another strategy. Yeah. We need, whenever we need to solve new problem, we need strategy. Yeah. For implementation. This one. Yeah. Actually, this strategy we already used before. In the previous slide, we use it. Here we just use it again. So the one is study a simpler case. Remember, we try simple examples, right? Similar, just different words, same meaning. Study a simpler case. So you can see this strategy is very useful. Although very simple, people may not pay attention to it, but it is extremely useful. Yeah. All right, now let's do the work. Okay. Simpler case, let us consider n equals 2. That is a simple, very simple case, right? Yeah. P2, so when n equals 2, our polynomial like this. Okay. So simple. So we won't be scared by this polynomial, right? If n equals 100, most of us may be scared by that expression. Think about that. So here n equals 2. So we have a lot of confidence dealing with this simple polynomial. All right. Now, what to do? Yeah. What to do next? Yeah. Observation. Okay? Observe. We need to observe this part, the last two terms. Can you find any property, special property regarding the last two terms? Yeah. A1 times x plus A2 times x squared. Okay? Yeah. The property is they have common factor x. Common factor x. That's the property. We want to take advantage of this property. Okay? To help us improve the performance. All right. Next, how to take advantage of this nice property. Okay. Here, let me give you another tactic. Yeah. So sometimes we use strategy, sometimes we use tactic. Okay. Another tactic. Yeah. So I don't know how to separate strategies or tactics. So usually strategy relatively big, tactic relatively small. Okay. Yeah. So this one is transform the problem. When you get stuck, okay, so when we solve a problem and we get stuck, we don't know how to solve. In that situation, we may like to transform the problem to a different form. Okay? To a different form. The fundamental is the same, but we need to change its representation form. That's the idea. Transform the problem. Okay? So this method, happens frequently. All right? Yeah. Why transform the problem can help us solve the problem? Look at this. Yeah. The reason is, after you transform the problem, you change the structure. After the structure change, you have a very good chance to get new outcome. That's the reason behind it. Here, let us do it. Okay? Because we have the common factor, so we can do some structure change regarding this common factor. Okay? What kind of structure change? Factorization. Common factor naturally corresponds to factorization. Yeah. So let's look at this factorization. The last two terms, they have a common factor. How about we just factorize that common factor out? Okay. So we have this expression. After we have this expression, now we want to enjoy the result. Okay, yeah. So how to get that? Let's count the number of multiplications at the left-hand side. How many multiplications at the left-hand side? The first term contributes 1 multiplication. The second term contributes 2 multiplication. The total 3 multiplications. How about the right-hand side expression? How many multiplications do we need for the right-hand side multiplication? First one here, this arrow. The second one here, this arrow. Total 2 multiplications. Can you see the difference? Can you see the different results here? Right? That's due to the property. We take advantage of that nice property and we get this result. Okay? All right, so now we can get our conclusion from this work. What is the conclusion? Factorization helps us to make a gain from 3 multiplications to 2 multiplications. That's the gain we enjoy. Right? All right. So that's the nice result we have seen. But this is for n equals 2 case. We want to extend, we want to generalize this result to the general case. So our next question is, can we generalize this idea to the general n? So think about that. Here we have the experience in n equals 2. Can we extend this method to cover the general n? That's our next topic. Yeah. So, but we finished our class today. That continued part we will do in our part B. All right.